On to problem 14.2, which is a typical modeling problem given for this linear to linear stuff. So, the problem is Oscar's hunting magnetic fields is Gauss meter, device for measuring the strength and polarity of magnetic fields. The reading on the meter will increase as Oscar gets closer to a magnet. Oscar's in a long hallway at the end of which is a room containing an extremely strong magnet. When he is far down the hallway from the room, the meter reads a level of 0.2. So I emphasize that far away. So that's an asymptote. They're telling us an asymptote. On all these problems, you look for the asymptote. So as distance, which is x, as x gets really big, as x is approaching infinity, way down at the end of the room, the meter reading is 0.2. So that's the horizontal asymptote is 0.2. And so we know that the horizontal asymptote is A, because we're going to model this thing as, let's see, y equals ax plus b over x plus c. So that's A, our horizontal asymptote is 0.2. Okay, because again, as x gets really big, b and c don't matter, and x divided by x cancels, and we get A left. That's how that works. Okay, now then they give us two other points. So when x is 6, the reading is, when he goes 6 feet into the room, it's 2.3. And when he goes 8 feet into the room, it gets stronger, it's 4.4. You always need three things because there's three letters we don't know, right? We don't know A, we don't know B, we don't know C. So we always need three pieces of information. Here we have an asymptote and 2 points. The easiest one is if they give us two asymptotes. Then we know A and we know C. Then it's real easy. But if they give us one, then we're going to have two equations and two unknowns. So this is going to be a two equation, two unknown problem. Question 14.5, they give you 3 points. So that's a three equations and three unknowns. You know x, you know y. You plug those into this equation, y equals axb plus x plus c. You have three equations because you know all the y's and x's, and you got to solve for a, b, and c. Those are tricky. 14.6, not so bad because they give you the horizontal asymptote. They give you A. So in all these word problems, you're looking for the asymptotes, you're looking for the other points, and then you can solve for our function here and graph it and answer the rest of the questions. Okay, so here they want our linear to linear model. So again, we know that A is this, so we can write that y, the magnetic field reading, is 0.2 x plus b divided by x plus c. Now we use our other points. 6 is equal to, because that's our y, yep, x is 2.3, and I'm getting this the wrong way. The value, this is our x, this is our y. Okay, so let me get this right. When y is 2.3, when the reading is 2.3, you're 6 feet in the room. So 0.2 times 6, x is 6, plus b divided by x is 6 plus c. And then when we go further into the room, the reading's 4.4 is equal to, let's see, x is 8, so 0.2 times 8 plus b divided by 8 plus c. Okay, now we have two equations, two things we don't know, so we can solve it. Unfortunately, it can be a lot of work, so now you just say, okay, take a deep breath and get ready to do lots of algebra. I think it's easiest to solve for b in one of these and then plug it in for b in the other one. It really doesn't matter. Or you could solve for c, plug in c into the other one. Let's solve for b and then plug the b into the other one just because you got to start somewhere. Okay, so I'm going to go back up here. I'm going to take this equation here, and I'm going to work in this space, and I'm going to solve for b. So I'm going to put my 6 plus c on the other side, multiply top and bottom by 6 plus c. So 2.3 times 6 plus c is equal to 0.2 times 6. That's 1.2, right? That's like 12 at a decimal place, 1.2. So 1.2 plus b. So let's see, 6 times 2.3 is 13.8. 6 times 2 is 12. 6 times 0.3 is, yeah, I think that's right. 13.8 plus 2.3c is equal to 1.2 plus b, or b is equal to, put the 1.2 over there, 2.3c. 13.8 minus 1.2 is 12.6, and you might want to check me on that, but since you can't tell me because it's a video, I guess maybe we'll just get it wrong and we'll find out later. Let's hope not. Okay, I think that's right. B is 2.3c plus 12.6. Now we can plug that into here. So we have, I'll just start it down here, 4.4 is equal to 0.2 times 8 is 1.6. So 1.6 plus b, which is 2.3c plus 12.6, all over 8 plus c. Let's multiply the 8 plus c to both sides. 8 times 4.4. It's getting tricky. I better not do it in my head because you guys aren't here to check me. So 4.4 times 8 is 35.2. So 8 times that is 35.2 plus 4.4c is equal to, let's see, we can add the 1.6 and the 12.6 together. That's 13.6, 14.2. 14.2 plus 2.3c. Okay, let's put the c's over here and those numbers over there. So we have 4.4c, I'll just show my work, 4.4c minus 2.3c equals 14.2 minus 35.2. 4.4 minus 2.3 is 2.1. Yes, I think that's right. 2.1c equals 4.2 minus 35.2 is, oh, 0.2's cancel, yeah, negative 21. Negative 21. So c is equal to negative 21 divided by 2.1. Wow, is that exactly 10? Negative 10? It is. Wow, that's pretty cool. Okay, so c is negative 10. Now we have our linear model. We know, oh, no, now we got to know what b is. B is 2.3c plus 12.6. C is negative 10. So finally, keep this organized here, b is 2.3 times negative 10 plus 12.6. That's negative 23 plus 12.6. And that is 12.6 minus 23. I get negative 10.4. So B is, wow, they're really close. B is negative 10.4, C is negative 10. So finally our linear model is the magnetic field strength is A, which we already knew A, that was 0.2, 0.2x plus B, B is negative 10.4, so I'll write minus 10.4, divided by x plus C, C is negative 10, so x minus 10. Okay, there's our linear model. Pretty cool. Hopefully it's right. Now let's do part B. B says, how far must you go for the meter to reach 10? How far to go to reach 100? Okay, so to reach 10, we just plug into our formula here. We want y to be 10, so this is part B. So we say 10 is equal to 0.2x minus 10.4 over x minus 10. Multiply both sides by the bottom. That's 10x minus 100. 10x minus 100, they got the x right, equals 0.2x minus 10.4. Put the x's over here. So 9.8x, I think, right? 10x minus 0.2x is 9.8x equals, put the 100 over there. So 100 minus 10.4, that'd be 89.6. I better do that in the calculator to make sure. And yeah, that's right. Or x is equal to 89.6 divided by 9.8, which is 9.14. That's good enough. So 9.14 meters. He goes in and it reads 10. Now what about 100? So let's do that over here. Same thing, just plug in 100. So 100 is equal to 0.2x minus 10.4 divided by x minus 10, multiplied by 100. We get 100x minus 1000 equals 0.2x minus 10.4. 100x minus 0.2x is 99.8x equals 1000 minus 10.4 minus 10.4, 989.6, or x is equal to 989.6 divided by 99.8, which is equal to 9.915, let's say 9.92 meters in. So it's getting big really fast, right? At 9.14 it's 10, a little bit further it's 100, and it looks like it's getting closer and closer to 10. Now we know it blows up at 10 because at x equals 10 it goes to infinity. So the closer you get to 10, the bigger it gets, and it'll get to infinity at 10. In other words, you're right on top of this magnet that's like infinitely strong. So that kind of makes sense. So part C says, considering your function and the results, how far in the room do you think the magnet is? So we just went over that. So at 10 meters it blows up, right? And we could just see that to 9.14 to 9.92. And we know because that's the y asymptote. That's where the function blows up. So that's the y asymptote. 10 asymptote has a y in it because our function has an x minus 10 in the bottom. So C was actually pretty easy. The other one's a little bit of work. Okay, that's how you do these. Again, let me go over that. The trick is you want to figure out what the three letters are here. Look for an asymptote. Either they give us the horizontal one. When you get really far away, what does it approach? If they give you the vertical one where it goes to infinity, where it blows up, C. And then some other points, and you got to do a bunch of algebra to figure out what the A and B and C are. Yeah, unless they give an asymptote. And then you can graph them like we did in 14.1 if they want you to graph it. So, okay, hope that helps. Good luck. Bye.